I wanted to take a few minutes to go through how to read and use the standard normal table. It is actually rather confusing, and the tables in your text, I think, are not the greatest tables in the world to use. But I've also found in the past that students prefer to use these tables as opposed to some alternatives. Why? Because there's an explanation in the text. So let's work out how to use these tables. I suggest that you open up your text, by the way, and turn to the Appendix B so you can follow along with me. All right, I hope you've done that, and let's get going. So these tables have z-scores down this column here, column A. There we go, down the column A are z-scores. To use the table, you're going to have to convert your raw scores into z-scores. And then it gives us two different areas underneath the normal curve. It gives us the area between the mean and a given z-score. This is the area shaded B. And it also gives us the mean between a z-score and the end of the table. Area C in both of these diagrams here is called the tail of the distribution. All right, suppose we're interested in finding out the proportion of students, the percentile of students, the probability. They're all the same when we're working with these distributions. They all effectively mean the same thing. Suppose we're interested in finding out the proportion of students, the percentile of students who are below a given z-value. You compute the z-value and you look it up in the table, okay? But you have to remember that what the table is giving us is it's just giving us this area in here. The proportion below this z-score includes that area that I've checked in blue. It also includes this area here. The table doesn't give that area to you. You have to remember for that type of problem that you need to add in the other half of the distribution. Because the normal distribution is symmetrical, the mean will always divide it in half, and the value of this area in red over here is equal to 0.5. So obviously you know that 50% of the values will fall below the mean, and 50% will fall, in this case over here, above the mean. All right, let's review a couple of features of the normal table, of the normal distribution that you need to remember. The normal distribution, again, is perfectly symmetrical. The horizontal axis shows z-values. The horizontal axis here shows z-values. The total area underneath the distribution is 1. And as I said before, the mean divides the distribution perfectly in half. All right, let's start out with the trick here. The trick in using the table is to understand what value it is that you're looking for. It is absolutely essential, I'll say it a third time, absolutely essential that you draw out a normal curve and make sure you mark on the curve the area that you're looking for. Let's say we have a distribution of scores with a mean of 200, a standard deviation of 5, and you're looking to find the proportion of students who fall below a score of 198. So the first thing we need to do is find a z-value for 198. So we have this is easy to do. Z equals 198 minus 200 divided by 5, and that is going to wind up equaling negative 0.4. All right, so we have a negative z-value. That means it's obviously going to be below 0, and I'll just sketch in about where that's going to be. And that's what you need to do when you work through these problems. You don't need a perfect looking distribution. You can just draw something quickly, but draw it out for yourself. We're looking at the proportion of students who fell at a score less than 198, which is a z-score equivalent of negative 0.4. So we're looking for this area over here. if you turn to your table and look down that column of z-scores, you're going to find two things. You're going to find the area between the mean and this z-score, which I will label, or I'll shade in red. And you're also going to find, as I said before, this area in the tail. For this kind of a problem, you want the area in the tail. And that area is going to be equal to 0.344 or thereabouts. I'm going to write it as P. We'll be using P later, but it's the same as saying percentile for all intents and purposes. So you can say now that 34.4% of the students scored below 198. So that's the first example that I'm going to give you. Let's move on to another one. Again, let me just reiterate. If our scores fall below the mean, if we have a negative z-score, which would mean that the score was below the mean, we're going to be reading the table, the tail section of the table. That's column C. Column C. This area here. They call it area beyond Z. Everybody else in the world calls it the tail of the distribution. Let's take a look at another one. In this case, let's have the same distribution with a mean of 200, a standard deviation of 5. And this time, we're looking at how many people scored below a score of 206. Again, first thing we need to do is compute the z-value. Z equals 206 minus 200 over 5. And that is going to work out to a value of 1.2. 1.2. Again, critical. You want to draw this out on the table. We're looking for the people who scored less than 206 or the z equivalent of 1.2. So if this here is a 2, let's say we're going to be maybe about here. Again, exactly where we place this doesn't matter. All right. So we're interested basically in this whole area over here. The tricky thing here is that the table is giving us this area between the mean and a z-score. That value, by the way, if you look at it, is going to be, I'll write it over here, area between mean and z equals 1.2 is 0.3849. Go take a look at your table and you'll see that that's the case. If you answer this question, if somebody asks you, what is the percentage of students that fall below a score of 206, z equivalent of 1.2, and you answer 38.49, you've gotten the question wrong. Why? Because we also need to include this area over here. So anytime, again, just using these particular tables, anytime you use these tables and you're looking for a proportion of folks that where the score you're given is a score above the mean, you need to add 0.5. So in fact, we'd have to go 0.5 plus 3849 rather, and that equals 0.8849. So we can say that about 88.5% of the students had a score on whatever this was of less than 206. Less than 206. Okay. Let's complicate things just a little bit now. And let's say we're interested in finding out the number of people, the proportion of people, I should say, who scored between 198 and 206. Well, we've already computed those z-scores, so we'll just bring them over from before, between a z of negative 0.4 and a z-value of 1.2. How do you solve this problem? Again, can't stress enough. We want to draw these out. And I think we put the 0.4 score about there. And we put the 1.2 score about there. Now let me fix that a little bit. Maybe it's going to be a little closer to here. So now we're interested in this area over here. So what do? Well, now we can use column B instead of column A. And we know from, we'll go back to our table, and we'll look up the value between the mean and a z-score of negative 0.4. And looking now in column B, we find out that this area in here, I'll shade it in gray, this area in here is equal to 0.1554. And then going back to our earlier problem, we found the probability, this red area here is 0.349. Oops. 0.349 and change. Won't worry about those decimals, but let me color that in. I'll do it in green. So this total area, if I sum up those, the green area and the gray area, I'm going to get, haven't done this one already, so let's just do it here, 0. About 50% of the students scored within that band of scores. About 50% scored within that band of scores. Okay, let's make things a little bit more complicated still. Okay, let's really complicate things now a bit, I'm afraid. Let's say that rather than looking for the proportion of students below a particular score, let's say we're looking to find the value, the score, at a particular percentile value. Let's say we're looking to find the score set at which 35% of the students do worse at that score. So we're looking here for the 35th percentile. Well, what do we know? We know that z equals x minus x bar over the standard deviation. And let's say that we know, as we did before, that x bar equals 200 and the standard deviation is equal to 5. All right, what do we want to do? We want to solve for x. In order to solve for x, we need to solve for z. So what do? Well, we go back to the table now, and instead of looking for z-scores, we look for proportions. We look in the section of the table that's headed, in this case, it will be either area A or, either area B or area C. So let's say we're looking for that 35th percentile. The 50th percentile is going to be this whole area over here. That's the 50th percentile. We're looking for the 35th percentile. So I'll just draw a line. Don't really know where I'll draw it. Doesn't really matter where I draw it. The idea is just to get the right direction of things. So we want to find out, what is that z-score? What is that z-score? So we're going to go to our table, and we're going to look for the z-value in column C, the z-value in column C for an area of 0.35, or the 35th percentile. So if we do that, you'll find that the value associated with that is going to be z equals 0.38. Z equals 0.38. You can open up your table and verify that. The correct value is on the second page of the Z table, and it is about a quarter of the way down in the leftmost column, or I should say the Z value is in the leftmost column. You're going to look in column C, and you could have chosen 0.38 or 0.39. 0.39, I suppose, is a bit closer. We're not going to bother interpolating these, but I'm going to stick with 0.38 because that's the way I work this out. So the Z value is 0.38, and then we just have to solve the equation. So we're going to have 0.38 equals x minus 200 divided by 5. So we multiply both sides by 5, and we get 1.9 equals x minus 200. Okay? And if we solve for x, by adding 200 to both sides of this equation, we're going to get a score of 201.9. Is that correct? No, it's not correct. It's wrong. How do I know it's wrong? Because we're looking for the 35th percentile here. We're looking for the 35th percentile. That percentile amount is less than the mean. Yet the mean I know is 200, and my value came up as above 200. So here's where you have to be careful. Here is where you need to be careful. Let me erase these. And let's remember, we're okay so far over here, but let's remember that this is actually a negative Z value. If the score you're trying to find is below the 50th percentile, you need to multiply the Z value you get from the table by -1. So in this case, we're going to have negative 1.9 equals x plus 200. If we add 200 to both sides of this equation, we're going to get 198.1. So the score at the 35th percentile is 198.1 if you use the tail of the table, which is, I think, a little bit easier to do it that way. So the tricky part in all this is you have to remember where you are in the problem, and you have to know what the table is telling you. And I think the best way to do that is to, again, draw this out. It didn't make any sense that the correct score would be 201. We're looking for the 35th percentile. It's got to be less than the mean. So we have to make that a negative. All right, let's tackle one more problem. Let's say we're looking now for the score at the 90th percentile. We're looking at that score below which 90% of our students scored, the 90th percentile. So we know the 90th percentile is going to be somewhere out here. It's going to be to the right of the mean value. It's going to be to the right of the mean value. Now, unfortunately, our table is only going to give us this area in here. There is no proportion, probability, percentile, what have you. There is no listing for the entire 90th percentile. So what we need to do is we need to look just for this section in order to get that z-score that we need. We need to get this z-score, whatever it happens to be. So if we're looking for the 90th percentile, and we know that the 50th percent is not included, we're looking for that score at the 40th percentile. That'll give us this area in here, which in turn will give us this value over there. So again, we're going to go to the table, and again, we're going to look at the body of the table. We're going to look at the proportions, not the z-scores. And if you look on the second page, and again, we're interested in column B here because column B is showing us the area between the mean and a given z-score. So we want to look through that part of the, we want to look through the tables, we want to look through the probability tables, the proportion tables, for something close to the 40th percentile and find the z-score. I think the one that you're going to find that's closest is located on the right-hand side of the second page, about maybe a third of the way down. Something like 0.3997, I think. And I'm going to, and the z-score associated with that is equal to 1.28. All right, so now what do? Well, same thing we did before. We're going to have 1.28 equals x, what we're trying to solve for, minus 200 divided by 5. Okay, so all I need to do now is multiply both sides of this equation by this 5, and that's going to give me 6.25 over there equals x minus 200. Now I'm going to add 200 to both sides of the equation, and I'm going to get 206.25 equals x. So the score at the, so 90% of our students scored 206.25 or less. 90% of our students scored somewhere in this area over here. Okay? I know these are tricky, and it really requires a lot of studying to understand what's going on. I would suggest that you may want to watch this video more than once. You may want to try to solve some of these problems on your own, and then check my answers and check how I work through them. And you may want to Google this up on the internet. Take a look for resources from the Khan Academy. Look for videos by this guy. His name is Brandon. I think it's Brandon Soltz, I think is his name. I believe I have a link to this up somewhere, and you can also look at, you can also Google on your own. But rather than trying to memorize how to solve these particular problems, try to understand what this table allows you to do and how the table works in terms of the characteristics of the normal distribution. Remember, everything under the table here is equal to 1. Column B is giving you from the mean to a given z-score. Column C is giving you this here, the tail of the distribution. It could be either the tail on the positive side, or it could be the tail on the negative side, and that's what you see over here. So don't forget to keep in mind, are we below the mean or above the mean? And the most important thing I can tell you is draw out these curves. Definitely want to draw out these curves. Okay, I hope you found this useful.